Hi friends and my dear students, Physics second volume 7.35 Electron microscope. Electron microscope. Electron microscope is invented by means of the application of matter waves particles. Matter of waves of the particle. Here in the board we are able to visualize two pictures. The one is ordinary microscope, the second one is electron microscope. As per the Louis de Broglie, he already told that the wavelength of an electron determined in the last class, and because of that reason we are invented this electron microscope. What's the fundamental basic principles that we are used to construct this electron microscope is the resolving power of microscope inversely proportional to the wavelength of the incident ray on the object. Incident ray of the object. When you are utilizing the ordinary light rays, for ordinary microscope or optical microscope. In optical microscope, we are utilizing the light rays from the source, and here the wavelength is very much greater than the wavelength of electrons. That is, the wavelength of electrons is very very less. When we are utilizing ordinary light rays for the optical microscope, then the same working condition is used in electron microscope. Instead of the incident ray is electron ray or matter waves or electron waves. That's a major difference. Here now we are going to explain the apparatus setup. Here the light source, the ray which comes from the light source are hitting the surface of the condenser lens, then it may be converge on the focusing on the object, so that it may be magnified by means of objective lens, and we are able to get intermediate image. Then it is not possible to visualize it. That's why we are using projector lens. By using projector lens, again it may be the ray which will be developed at last to hit the surface of the screen, and we are able to visualize this object to magnified object. That is called optical microscope. Instead of optical microscope, here the light rays wavelength is higher, far higher than the electron microscope. That's why the resolving power of the on an optical microscope is less than electron microscope. That's a very important concept. In electron microscope, instead of light source, we are utilizing the electron source with the filament. It is whenever we are applying the voltage to the electron filament, then automatically it will emit the electrons, so that by applying the electrostatic or magnetic field to this charged particle of electron beam, then we are able to converge this ray in a particular object or focusing this ray in a particular point or particular object. That is the principle that we are utilizing here. Instead of condenser lens, we are using electric field or magnetic field, because the electric field or magnetic field, when you are applying, here the electron rays are moving. When you are applying the positive or negative, this is negatively charged particle, so that path may be deviated. And because of this property, we are able to converge this electron ray on a particular spot or on the image. That's a very good application of this electrostatic or magnetic field or electric field. Now, this is called condenser lens. Condenser lens or using the electric field or magnetic field. In the same manner, we are utilizing object lens or projector lens are also made up of electrostatic or electric field or magnetic field lens. Now, these coils or this electric field or magnetic field, which will be able to converge this ray on the object so that it will be magnified and falls on the intermediate lens, intermediate image. This is called intermediate image. We are able to get intermediate image because of this help of this objective lens and as well as condenser lens. Now, in order to visualize this image, I think it is very difficult to visualize. That's why we are applying photographic plate to take this photo and visualize. We are able to visualize it. I mean, a photographic plate. For that, we are utilizing projector lens. Here, the main property or main principle what we are used here is the very important, the resolving power of either optical or electron microscope is inversely proportional to the wavelength of the incident ray on object, incident ray of object. Here we are utilizing matter waves or electron rays. Electron rays or matter waves. Electron rays itself considered to be a matter waves, so that the matter waves which will focus on the object with the help of condenser lens on the object, so that it may be magnified. Then objective lens which will focus the image, magnified image on the intermediate image, so that again once again projector lens which will focus this intermediate image on the photographic plate. Then here, to understand clearly, lambda is the wavelength. When the wavelength is lesser, then resolving power will be high. If you reduce the wavelength is furthermore, then furthermore the resolving power of the microscope which will be increased, or magnification which will be increased. Magnification or resolving power are inversely proportional to lambda. Inversely proportional to lambda or proportional to 1 by lambda. That's a very important principle. But here matter waves, we are utilizing the matter waves or electron rays very lesser wavelength so that high resolving power, high resolving power as well as high magnification, high magnification, magnification. That's a very important concept to understand this electron microscope. Very simple question and very ordinary question, but the users Louis de Broglie suggested that in last class I told already for you all why he gave more importance to identify the wavelength of an electron to construct this electron microscope. Construct the electron microscope. Under this principle, when the resolving power or magnification power is higher when we are utilizing the lower wavelength of incident ray, lower wavelength of hitting rays of an object. That's a working condition and apparatus of the electron microscope. I think it is very easy question for your plus 2 syllabus. I hope you may understand clearly. Thank you.